Okay, for the introduction of the plate and frame filtration process, this experiment is basically about the filtration process through the usage of the plate and the frame. In this filtration, the cake from the process, which is the calcium carbonate, will be removed, and the comparison of its filtrate in liter to its original volume, which is 3 kilogram, in order to determine the loss of quantity of calcium carbonate. Also, this experiment is also to determine the viscosity and the density of the filtrate. The calcium carbonate solution will be feed into the filtration cycle by the slurry pump from the mixture machine, and then the suitable pressure for the filtration with the solution will begin to go through the filter plate. The filtrate will go through the plate, and while the solid retain in the cake chamber, and at the end the weight of the solid is measured, and in order to determine the loss quantity of the calcium carbonate. Okay, for the introduction, for solid liquid extraction, is the method of separating the soluble component, or we call it solute, from its solid mixture with the usage of a solvent in the form of liquid. Solvent is selectively dissolved the desired solute, while the remaining component from the solid mixture is insoluble and remain the solid. Okay, for the objective of the experiment, the first objective is to run the operation of filter press for filtration of calcium carbonate slurry. The second objective is to record the data of filtrate volume against time. And third is to find the time when the filtrate volume is the lowest. And fourth is to determine the filtration time to completion. And the last objective is to determine the loss quantity of calcium carbonate after the filtration process.
I'm going to tell you about the 4 theory parts. There is 4 theory that will affect for this experiment. First, particle size. Second is the solvent. Third, for temperature, and lastly for agitation of fluid. First, I will tell you about the particle size. So the smaller the particle size, the increase of the extraction process. This is because the small particle has the large area compared to the big particle which has a low surface area. Next, for the solvent. For the solvent, the good selectivity is very important. This is because the good selectivity has a low viscosity. When it has a low viscosity, it will circulate freely, and at the same time it will increase the extraction process. For the temperature, the higher the temperature, the higher the extraction process. This is because when the higher the temperature, the higher the solubility of component to extract from solid material to liquid solvent. For agitation fluid, mostly it refers to the solvent for this theory. If a solvent has more turbulent flow, it will increase amount of component solid mixture to dissolve. This is because increase of the transfer from the solid mixture to liquid solvent. So at the same time, it will increase the extraction process.
Okay, for the experimental procedure, first we open the air regulator valve.
Second, we check the pressure gauge setting. Third, we release the hydraulic pump air valve and the operation valve anti-clockwise. And the fourth, we fed the filter by moving forward the stationary, and at the same time, we make sure the filter is very close and there is no waste form. After that, we move the moving pattern towards each other by using the hydraulic pump, by using the lever. Okay, after that, we put the pervasive drag strip until here to here. We start the hydraulic pump until it reaches the required pressure. Then we lock by turning the operation valve here by clockwise. Okay, on the control panel, we put the start button and the green light of the run we turn on. Okay, then when feeding the slow slurry into the filter, reach the preset timing, the pump will stop and the light will turn off. Okay, finally, we close the air regulator valve and slowly open the inlet valve. That's it.
Now, I want to explain how to calculate solid liquid extraction. For the general information, solid liquid extraction have three component mixtures can be represented on a right angle triangular diagram. Solid liquid extraction have three general formula, which is mass fraction of solute, mass fraction of solvent, and mass fraction of inert. As you can see, D is mass fraction of solute, Ya times K over 1 plus K, and this formula for mass fraction of solvent, K times Y minus Ya over 1 plus K, and this is formula for mass fraction of inert, 1 over K plus 1. So, Ya stands for mass of solute over pound of solution in the overflow, and K stands for mass of solution removed in the underflow per unit mass of solid. Before you want to plot the graph, we have to find overflow and underflow. As you can see, this is the formula for overflow. Y equal to component over solvent plus solute, and we want to find the Ys. How to find the Ys? 1 minus Ya. And this is the formula for underflow. This for the general formula is component over solvent plus solute and plus carrier. This is also to find the SS, which is 1 minus SA plus SB. So, how to construct graph by right triangular diagram? For the first step is plot line for all underflow, which is SS against SA. For the second step, material balance to find outgoing overflow. For the third step, three different points F lies on a straight line through S0 and Y1. For the fourth step, F prime is constant and thus Sn and Sn plus 1 and F prime also lies on a common line. Sn is on the line for all underflow. For the fifth step, find S by drawing the line from origo to Y. 6. Find Y2 by connect F prime, Sn and overflow line. And the last step is off until Sn decrease Sn.
For the recommendation of this experiment, make sure the slurry tank has enough slurry before operating pump. Then, air regulator valve should be closed. Inlet valve should be open to gain the product of film drain and separate water from film drain. Okay, for the third recommendation of this experiment, it is important to make sure the calcium carbonate powder weight is correct. Then, lastly, the plate was not blessed, which this may cause the broken clothes and the faulty plate that can be isolated. Safety first.
As a conclusion for the experiment, all of the objective for the experiment was achieved. In order to separate the desired solid constituent or remove any undesirable solute component from the solid phase, which is calcium carbonate, and the solid is contact with a liquid phase, which is water, you used in this experiment. So, when two phases with solid and liquid are intimate contact and the solute can diffuse from the solid to the liquid phase, which causes separation of the component originating in the solid, that was called the solid-liquid excretion.